class, this is now another type in relation to integral calculus where we solve the area or the section at which a particular curve is plotted with. Or remember your parabolic curve equations before, as well as your line equations, slope plotting equations, and so forth and so long before. This time we can solve that. We can solve the area bounded by that curve or that parabolic curve or that particular line or slope within a plane using integral calculus, which we call as the area bounded by a curve. In solving the area bounded by a curve, you need to remember your basic analytic geometry and trigonometry, as well as your algebra before, on how are you going to plot whether a parabolic curve is facing to the left, facing to the right, facing upward or downward. But I'll teach you later a basic concept on how are you going to interpret whether they are left or right, opening upward or downward. Very easy. Sobrang dali. Paano nyo ma-interpret yun? Now, first up, how are you going to compute? This is just my own solution process on me solving problems involving area bounded by curves. Hindi nyo ito mahirap tong mabasa sa libro. First stop is for you to sketch up your curve. Sketch the area or the section of curves. So, after you have identified kung yung curve natin is upward, downward, left or right, and so forth and so long, based on the given equation, pwede mo na siyang sketch in your the x and y coordinate system. Then, take a representative element. Pag sinabi nating take a representative element, within that specific section, kukuha tayo ng maliit na strip which will represent our limits in defining later on what are our upper and lower limit of the given curve. Representative strip, where we can solve in this particular topic or this particular section the differential area at which this particular parabolic curve or section bounds or revolves. Area of a rectangle, area of a circle, area of parabolic, and so forth and so long. Right? How are we going to define the horizontal elements or representative of a parabolic curve? So with that, either way naman parehas lang yan. Kung if you're going to consider horizontal or vertical strip of a curve or of a parabolic curve, parehong area lang naman yung mababound nung strip na yon. Horizontal elements. So for horizontal elements, if now our parabolic curve, hindi ko na i-drawing ng buo yung parabolic curve. Parabolic curve is facing to the right, such as shown here. Remember your latus rectum, your vertex, your maximum minimum value, your h and k, and so forth and so on. Halimbawa, ang vertex natin is at point 0 at origin. And our latus rectum, tama ba? Latus rectum ba yun? Tama. And our latus rectum or the focal length is here. This is your 2A. So, pag horizontal element, we need to dissect a section within a curve horizontally. Dissect a section within the curve horizontally. Halimbawa, ito yung ating representative element strip. Sa element strip na yan, on the right side, it is now touching the curve or the equation which represent the curve. Let us consider that as x left. And the right side of this strip, it is now touching the boundary or the focal length which represents the ending or the boundary of our curve, which shows our x right. So, halimbawa, ito yung ating x right and ito yung ating x left. And remember, this is your parabola. Hindi lang parabola ha, minsan meron tayong equations, combination of parabolic curve dissected by a line. Hanapin nyo yung intersection ni parabolic at saka ni line, and so forth and so long. Or combination of a hyperbolic line or hyperbolic curve with a dissecting line, and so forth and so long. And let us consider our strip as a differential variable y, which is now the thickness of an element. Thickness of an element. Kaya dy, kasi hindi pa naman natin sure kung ano yung thickness na yan. Kasi nga, we need to differentiate it first to identify the thickness. Or nag-assume tayo or nag-take tayo ng representative strip which will define the area of the curve. And this one is our boundary line. Okay? Now, for us to take the entire area of this parabolic curve, we will then consider the strip will rotate all over the x-axis. Iikot yan throughout the x-axis. Ito yung strip, gaganyan siya. Okay? So, pag umikot siya, ang makukuha nating area is yung upper curve at saka yung lower curve. Right? Imagine nyo lang na umikot siya but not literally umikot siya. Kasi sa iba yun, solid revolution naman yun na discussion. Pero with this, yung half lang naman ang kinonsider natin for the formula. Imagine na umikot siya. So, ang magiging limits natin is from this point to this point. Which is in terms of y. Right? So, the area bounded by this parabolic curve is equal to the differential area equal now to the identified line touches by the strip, assume x right minus x left. Then, dy. Then, integrate para maging a yon. Integrate. And your limits are y is to y. So, dito to dito. From this point to this point. So, ito yung lower limit. Ito yung upper limit. Kung yung curve ninyo na nasa negative quadrant, so then the maximum limit is a 0. So, ang lower limit natin is negative. Then, upper limit is 0. And so forth and so long. Which is now basically, this is now basically our general formula if we're going to consider horizontal element. Either way, kung vertical element naman ang i-consider natin, parehas lang yung area na makukumpute natin with this one. Next up, let us try to derive the horizon using derive the area or formula area using a vertical strip. So for vertical strip, vertical elements. Vertical elements, ganun ulit. Let's make our Cartesian lines. Then your parabolic curve. Assume or identify your boundary line kung nasaan yung iyong focal length. Then apply a vertical. Consider a vertical strip. Vertical strip. Okay. So sa vertical strip na yan, meron tayong dx thickness of the line. Thickness of the element strip na consider natin. Then, the point at which the upper corner of the strip touches is the section where we have defined our curve. Consider that as your y top. And the point where touching the strip below is our equation for y bottom. Okay? Then again, you have your boundary line, your focal length, or later on for a latus rectum, then your vertex or vertex. Kailangan nyo i-compute yung vertex ha. Hindi yan laging at an origin. Hindi yan laging at 0. Later sa examples, merong vertex na at quadrant 2, quadrant 3, or quadrant 4. Then that particular parabolic curve is now dissected by a line equation. We need to compute first kung nasaan yung ating verse. This is just a mathematical representation on how did we arrive with this formula. Okay? And later on, we will be able to compute the length of that arc or the arc length of our parabolic line. So same goes with the formula of considering horizontal elements. Area is equal to the differential area of the assumed strip element times equal now to the difference of the top equation minus the bottom equation times the thickness of the strip. Then integrate both sides and apply your limits. So, ang limits natin ngayon, imagine vertical strip. To consider the entire area of the parabolic curve, saan siya magre-revolve? Sa x pa ba or sa y na? Sa x o sa y? Sa y na siya imagine that it will rotate along y-axis. So if it is going to rotate along y-axis, ang limits natin is from the origin or the vertex towards the boundary. Kapag umiikot siyang ganon, this is now x bottom, lower limit, and x upper limit. Okay? Then y top minus y bottom. Okay? And that will serve as our equation in solving the area bounded by a curve using either horizontal elements or vertical elements. Okay? Now, sabi ko kanina, we are going to review your knowledge when it comes to parabolic plotting of parabolic curves. Okay? Narinig pa po ba ako? Nababasa pa?
Yes, sir.
I hope you could still remember your knowledge when it comes to parabolic curve. So with parabolic curve, hindi ko naman pwedeng gawan ng separate video to, hindi naman to part ng calculus. So parabolic curves, remember the general form of parabolic curve is ax squared plus bx plus cy plus d equal 0. Or if it is in y-axis, that is ay squared plus by plus cx plus d equal to 0. Such that the standard form of a parabolic curve by using completing the square is either x minus h squared equal to plus minus 4a of y minus k. And lastly, y minus k squared equal to plus minus 4a x minus h. Now, alam niyo pa ba kung paano niyo i-interpret yung parabolic curve if it is opening right, left, up, or down? Alam niyo pa ba? Alam pa ba? You still remember? Now, if the parabolic curve is in reference with the x-axis, laging ang completing the square natin is starting at x minus h squared, such as the latus rectum and the focal length will be in reference to the x-axis. And if it is in regards to the vertical axis, laging ang completing square natin mag-start with y minus k squared. And the latus rectum and the focal length 4a will be in reference to the vertical axis. Ngayon, ang problema na lang is si positive, negative. Positive, negative. First equation represents a parabolic curve that is in x-axis. But how do we determine if it is opening upward or downward? Now, if it is in x-axis, our parabolic curve will open upward if it is positive. If 4a is positive, dito pala, wait lang. If 4a is positive, the parabolic curve will open upward. And if it is negative 4a, the parabolic curve will open downward. Now, if the completing square or the parabolic curve shows that it is now in terms of y-axis, positive 4a represent that the parabolic curve is opening to the right. And if it is negative 4a, the parabolic curve is opening to the left. Upward, downward, to the right, to the left. Okay? That is if your if your vertex is at 0 It's at 0. Ito yung HK natin. Yung HK, after computing or completing the square, makukuha nyo na yan daan sa equation, which is your vertices. Okay? Sulat ko na nga lang. H and K are the vertex of a parabola. So if your parabola is plotted this way, let's just say your parabola is opening to the right. Identify lang natin yung parts niya. This will serve as our boundary line. Your vertex, if your vertex is at origin, kung 0, 0 ha. Your vertex, your boundary line, two A is your focal length, and 4A, 2A plus 2A, 4A is your latus rectum. Then, ano ba to? Then, the distance from your directrix and the distance from your vertex towards your boundary line should all be equal to A. This is now your directrix, and your A is your distance from the center of the directrix or from the center of a focus. So that is the parts of your parabolic curve. Okay? If it is if it is opening to the right, positive 4A. Either way, kung opening upward, downward, or to the left, ganyan pa rin naman yung parts nun. 4A is your latus rectum, 2A is your focal length, and A is your distance from the center of the directrix or from the center or from your focus. Then H and K is the location of your vertex or point of curve. Okay? Oras na ba? Now for our example, for our area bounded by a curve, let us try to solve this given the area of this given parabolic curve. So how are we going to determine if this is a parabolic curve given that is a y squared equal to 16x? Refer again to our parabolic curves equation in its general form, right? If it is y squared, therefore that is y minus k squared, which is equal to either positive negative 4a of x minus h. That is y minus k squared. Refer to the given equation, which is y squared. Therefore, our k is simply equal to 0. Wala namang constant. Then that is 16. Positive 16. So that is positive 4a, which is equal to 16. Then x. Walang constant. So h is simply equal to 0. Now, the location of our vertex is basically on the origin, 0 to 0. While 4a, or the length of our latus rectum, is equal to 16. Tawag na nito. Divide both sides by 4. The distance to the directrix to the focus is simply equal to the 4. And multiply a with 2, which is our focal length, is now equal to 8. So there are two ways in which we can solve the area bounded by this particular curve, using either the horizontal strip element or the vertical element. Lagay lang natin yung datas natin. 4 is equal, A is equal to 4. Focal length is equal to 8. Is equal to 8. And the vertex is basically equal to 0. Is the vertex located at the origin? Remember that it is acting, it is in terms of the y-axis, and it is a positive 4a. If it is y-axis, positive 4a, therefore it is opening to the right. So, gamitin na lang natin yung figure natin dito. Let us start considering or using the formula considering a vertical strip or a vertical element. Consider a strip within a curve. Kahit hindi na natin gamitin yung curve sa baba, okay lang yan. ano naman natin, kasama na siya dun sa equation. Okay? Consider a vertical strip considering the parabolic curve. Then that strip has a thickness of dx. Take note that a part of that strip is your parabolic curve, which consider as y top or upper hand. And the part of that strip is considered y-axis, which is your y. Remember that your curve is equal now to y squared equal to 16x. We need to represent that equation in terms of variable x. That is y squared equal to 16x, or y equal to the square root of 16x. Or simply, that is also a part of our vertical strip, y top. Y top is square root of 16. While y bottom or lower hand has a part of the strip is the x-axis, which is at the origin. So that is simply equal to 0. Then our limits now, considering that this strip will rotate along y-axis. So ang limit natin, the revolution or the rotation will start at this point and will end at this point. Okay. So that is your x lower limit and x upper limit, which is 0 at the origin. And the upper limit, saan siya natapos? 0 hanggang doon sa boundary line, which is equal to 4. Remember our formula for area, determining area considering a vertical strip, that is integral of the differential area is equal to the integral of y top minus y bottom dx. Then your x lower limit and x upper limit. Meron na tayo ng mga variables na yan. Substitute na lang natin. 0 to 4, y top is square root of 16x minus 0 dx. Using your own calculator, you can immediately solve for the area. Meron niyang integral using definite integral. But later on, hindi ko na kayo masyadong i-require with that particular solution. Just show the direct drawing on how did you arrive with that equation. Yung kagaya nitong drawing natin dito. So, ngayon, isosolve ko lang. Pakita ko lang paano na-solve. That is equals square root of 16x, that is 4, 0 to 4 of x raised to 1 half dx, which is equal to 4x raised to 1 half plus 1, which is 3 halves, over 3 halves, plus c, and a is equal to 8 over 3, x raised to 3 halves, plus c. Then apply your upper and lower limit of 0 to 4. That is 8 over 3 of 4 raised to 3 halves minus 0. Basically, 0 na yung next term. So, area of the parabolic curve or area bounded by the curve using a vertical element is equal to 21.33 square units. Okay? So, yun ay answer natin if we are going to use a vertical strip. How about if we're going to use a horizontal element? If it is a horizontal element, again, consider a horizontal strip on the curve. Ito yung horizontal strip natin. Such that the thickness of that strip is now the differential of y. Ano yung strip natin? On this section, that strip considers a part of the parabolic curve. Let us consider that as x left. And on this section, our horizontal strip considers a part of the boundary line, such that boundary line is now your x right. Okay. Ngayon, horizontal elements. Ngayon, si x left is considering a part of the parabolic line. So we'll need to interpret that parabolic line into an x equation in terms of x. So that is y squared equal to 16x, or x is equal to y squared over 16, which is also your x left. And x right is considering a part of the boundary line, where the boundary line located at 4 of the x-axis, or your distance from the focus to the boundary line, which is 4. So x right is equal 4. How about your upper and lower limit? Remember na papaikutin natin yung ating curve. So if we're going to make our curve rotate on such manner, it will start at this point and will eventually consider also that point. So that is your lower limit, and this will be your upper limit. The lower limit is equal to 0. Upper limit is equal to 8. Kasi 2a yun, length of focal length. So substitute lang natin sa formula natin for horizontal element. Integral of differential area is equal to the integral of the lower limit YL, upper limit YU, x right minus x left dy. So dapat lahat yan ay in terms of variable y, kasi strip natin is dy. So substitute lang natin 0, 8. Mapapansin nyo yung mga ordinates natin, yung mga upper and lower limit natin are in terms of y-axis ordinates. X right is the equation of the curve in terms of x-axis. That is y squared over 16 minus, x right pala. X right is 4, x left is y squared over 16 dy. So lahat na in terms of y. Distribute lang natin, that is 0 to 8 dy minus 1/16 integral of 0 to 8 y squared. Basic, apply your knowledge with integral formulas for y minus 1 y cube to 3 times 16, 48 times y cube plus c. Apply your upper and lower limits. A is equal to 4 times 8 minus 1 over 48 times 8 raised to 3 minus 0 times 4, substitute lang natin, 0 times 4 is 0, minus 1 over 48, 0 cube is also 0. So that is 0. A, or the area now, is simply equal. The area now is simply equal to also 21.33 square units. Remember that area ang pinag-uusapan. So wag kakalimutan yung 21.33 square units. Square units. Area ang pinag-uusapan ha. So wag kakalimutan yan. So with that said, try to solve this next problem. Find the area bounded find the area bounded by the curves and lines. By the curves and lines. 2x squared plus 4x plus y equal to 0 and y equal to 2x. So, makikita nyo na dyan kung nasaan yung line at saka yung may curve. 2x squared plus 4x plus y equal to 0. Then y is equal to 2x. Saan dyan si parabola? Saan dyan si line? Then define their intersection points. Compute for the area and so forth and so on. using either horizontal or vertical strip. Pero merong section na mas madali ang gamitin ang horizontal kaysa kay vertical strip. Ay, mas madaling gamitin si vertical kaysa kay horizontal strip.